Okay, let's just dive right in. If you've ever stared at a huge list of geometry formulas and just felt your brain kinda shut down, well, you are in exactly the right place. Today, we're gonna unlock a master trick that will free you from having to memorize all that stuff for good.
Right? Does this look familiar? This huge, intimidating list of formulas for cubes, cylinders, spheres. It's a lot. It can make you feel like you have to be some kind of math genius just to keep it all straight. But I promise you, that is not the case.
But what if I told you there's a way to actually build, to construct almost all of these complicated looking formulas from just four simple shapes that, let's be honest, you've known since grade school? That is the secret we're unlocking today.
But hey, before we start building anything, we gotta make sure our foundation is solid. So let's get one core idea perfectly clear: the difference between volume and surface area.
It's actually way simpler than it sounds. So think of it like this. Volume is the enclosed space. It's everything inside an object. If you were to fill a box with water, the volume is how much water it holds. Surface area, on the other hand, is the object's skin. If you wanted to gift wrap that same box, the surface area is exactly how much wrapping paper you'd need to cover it. That's it.
All right, with that sorted, let's get to the really cool part. We are about to witness a little bit of magic. We're going to see how these big 3D volumes are really just flat 2D shapes that have been stretched out. Okay, so here they are, our four fundamental building blocks. You definitely know these by heart: the area of a square, a rectangle, a circle, and a triangle. I'm telling you, if you know these four, you have the power to build pretty much any volume or surface area formula you're ever going to need. So here's the crucial idea. You take a simple square, right? Its area is a squared. Now, just imagine grabbing that flat square and pulling it straight up, giving it a height that's the same as its side length, a. And what have you just made? A perfect cube. So what's its volume? Well, it's just that base area, a squared, multiplied by the height you pulled it, a. That gives us a cubed. That's literally all it is.
Let's see that same logic in action again. We can do the exact same thing with a rectangle. Its base area is length times width. You pull it upwards by some height h and bam, you get a cuboid, like a brick. The volume is, you guessed it, the base area length times width times the height.
And this is where the pattern really starts to click. Start with a flat circle on the ground. Its area is pi r squared. Now extend it straight up by a height h. You've just made a cylinder, like a can of soda, so its volume is just the area of that circle, pi r squared, multiplied by the height. See? It's the same trick every time. Base area times height.
Now, you might be wondering, well, what about cones and spheres? What's really cool is they follow a similar logic, but instead of just stretching a shape upwards, we create them by rotating a 2D shape around an axis. For instance, you can make a cone by spinning a triangle, and a sphere by spinning a semicircle. The math for why this works involves calculus, which is a little beyond what we're doing today. But for now, just know they come from the exact same building block idea.
Okay, so we've totally mastered building volumes. Now, what about surface area, the skin of the object? Well, we're gonna do the complete opposite. Instead of building the shapes up, we're gonna unfold them, lay them out flat. Imagine we take a cube and kaboom, we just explode it so all its faces lay out flat. What do you think we're gonna see? You get count 'em, 6 identical squares. And we already know the area of one of those squares is just a squared. So the total surface area is simply 6 times a squared. Easy. And if you ever hear someone talk about lateral surface area, that just means the area of the sides without the top or the bottom. So for a cube, that's just 4 of those squares.
Okay, this next one is my absolute favorite. Let's take a cylinder and see what happens when we unroll it.
When you unroll a cylinder, you get 3 super simple pieces. You get a circle for the top, a circle for the bottom, and the curved side, it unrolls into a perfect rectangle. Now, the height of that rectangle is obviously h, but what's its length? Well, it's the distance it was wrapped around the circle, which is just the circle's circumference, 2 pi r. So the total surface area is just the area of the 2 circles plus the area of that one rectangle. It's brilliant.
And just a quick heads up on the lingo. You'll hear lateral surface area for shapes with flat sides and curved surface area for things like cylinders. They both mean the exact same thing, just the area of the sides. You just don't count the lid or the floor.
Okay, we have covered a ton of ground. So let's pull it all together and recap this master trick so you can walk away with a crystal clear method. So here it is, your new cheat sheet. But look, it's not really a cheat sheet anymore, is it? Because now you can look at every single one of these formulas and see exactly where it came from. You see the cube's volume, a cubed. You know that's just its base, a squared, times its height, a. You see the cylinder's surface area, and you know that's just two circles and a rectangle. It all makes perfect sense now. And that right there, that's the whole point. The goal is never to just memorize a long, boring list of facts. It's to understand the simple logic hiding underneath it all. Because once you see the logic, you can't unsee it. And that's the real power you're walking away with today. You haven't just learned some formulas. You've learned how to think differently. You now have the ability to sit down with a blank piece of paper and completely rebuild these formulas from scratch, anytime, anywhere. And that kind of leaves us with one last question to chew on. If geometry can be broken down this simply, what other complex subjects in our lives are really just a few core ideas, all combined, just waiting for us to figure them out? Something to think about. Thanks so much for hanging out with me today.